Let's have a look at practice question set number 4. Of course, that means we have quiz number 4 tomorrow. Question number 1 says a proton collides with a stationary alpha particle. After the collision, the proton moves at this speed, the direction opposite to its initial motion. The alpha particle moves forward in the same direction as the proton was initially moving. If we go back to our physics 30 and 13 pages document for a second, remember 15B said collision or explosion in any context. And what I mean by any context is that usually at this point in the year, we see questions involving things like cars or balls or something like that, right? Big things. But we can have collisions or explosions involving subatomic particles too, right? Like atoms or like protons or like alpha particles, whatever the heck an alpha particle is. We haven't even learned about that yet. We can see it in any context. It doesn't have to be macroscopic that we can physically see. It can be subatomic as well. All right, so what is an alpha particle? Well, we don't really know what an alpha particle is yet. We will later on in the year know what an alpha particle is. For now, I'll just tell you it's a particle that comes as a result of radioactivity. Okay? It doesn't really matter what it is right now. In the end, there's a collision. We need to know the mass and velocity and so on. Where do you think you're going to find the mass of this stuff? A proton and an alpha particle. If you don't know what the mass is, and odds are you don't, you might know what the mass of a proton is if you take chemistry, but probably not an alpha particle. Yeah, look on your data sheet. Like if you're ever missing something and you think you need it, check your data sheet. Maybe it's there. The mass of the alpha particle and the proton are there. I'm going to call the proton object number 1. I'm going to call the alpha particle object number 2. Now, I'm going to pull out the red pen for this one because there is some tricky wording in this question. I thought, at least, some tricky wording in this question. What is it? Like, what is it that could lead me to a mistake in this question? Besides, like, not knowing where to find a mass or something like that, right? What's red pennable in this one, Charles? Yeah, okay. I'm not going to circle that. Like for me, the scientific notation, the 10 to the 6, probably isn't going to lead me to anything, right? When it's on a graph axis, that tends to lead me to a mistake sometimes if I don't identify it. But in a question, probably not. But if that's something that leads you to a mistake, then you should circle that. Yeah, go ahead. Sorry? Okay. Oh, okay, sorry, yes. Yeah, absolutely. That's what I would draw attention to as well. We have this velocity in the opposite direction to its initial motion, and then the alpha particle moves in the same direction as the proton was initially moving. So not even the same direction as it was moving, but in the same direction as the proton was moving. So it's like kind of a reading exercise in this question almost to get the signs correct. Like it's not just, oh, this guy's moving north, this guy's moving south. Like same direction, opposite direction to what the other guy was moving and so on. Let's write down some givens here now. The mass of a proton, I'm going to call that M1, is 1.67 times 10 to the minus 27 kilograms. And that's on our data sheet. The mass of the alpha particle is 6.65 times 10 to the minus 27 kilograms. You probably didn't notice this, but the mass of the alpha particle ends up being 4 times the mass of a proton. And there's a reason for that. If you've taken chemistry, you know that a proton and a neutron weigh essentially the same. Not exactly, but essentially the same. And an alpha particle is made up of 2 protons and 2 neutrons. So that's why it's 4 times the mass of a proton. The alpha particle is stationary, so I'm going to say something is 0 meters per second. What is that going to be, V1 or V2? The alpha particle is initially stationary. Is that V1 or V2? Yep. V2, V2I, or V2F? Good. The initial velocity of the alpha particle is 0. After the collision, the proton moves. Okay, after the collision, the proton moves at 3.35 times 10 to the 6 meters per second. Is that V1 or V2? The proton. John, is that V1 or V2? After the collision, the proton moves at 3.35. We made the proton number 1, right? So that's going to be V. No, we made the proton number 1. And it says after the collision, the proton moves at this speed. So we're going to make it V. Yeah, no, that's right. No, it's F. Yeah, you're right. But it's V1F, right? Not V2F. Good? So you want to make that negative? Like, if we make it positive, and we can, then we assume the initial motion is negative, right? Because it's opposite to its initial motion. To me, it seems logical to consider your initial motion positive and the direction opposite to that negative. It's not a big deal if you leave it positive, but if you do, just make sure you understand what that means. The alpha particle moves forward afterwards in the same direction as the proton was initially moving. That's going to be V2, right, John? The alpha particle, and V2F because it's the final velocity of this alpha particle. 2.25 times 10 to the 6. Oops. Is that going to be positive or negative? Cash, is that positive or negative? 2.25 times 10 to the 6. The alpha particle moves in the same direction as the proton was initially moving. Yes. We made the initial motion positive, and therefore the 3.35 was negative, right? And therefore the 2.25 is positive. We could have reversed those signs and had positive and negative instead of negative and positive. No, this is the way we did it. We're looking for the initial speed of the proton. That would be V1I. Yeah, this is like the traffic accident, right? Where the police officer's trying to figure out how fast the car was moving before the collision, except that we're dealing with protons and alpha particles instead of cars. All right, so got to find some room here. Pi is equal to Pf. We'll say M1 V1I, because there's two objects, right? Plus M2 V2I. Or, McKinley, what could we say there instead of M2 V2I? Anybody? Yeah? I could just say 0, right? How come I could say 0? Yeah. Yeah, if you want to put M2 V2I, there's two objects, right? M1 V1I plus M2 V2I, you can do that. But if you recognize that one or both are 0, you can just kind of scratch that out. In fact, if you wanted to, you wouldn't even have to put a 0 in here. You could just say M1 V1I equals. Make sense? I'm putting it in there, but you don't have to. Now, there are two objects afterwards, so we're going to have M1 V1F plus M2 V2F. Now we start subbing numbers in, right? We're looking for V1I here. So M1, oh, you know what? Anybody spot a little shortcut here? I didn't think about that when I first started this question, but there is a bit of a shortcut here that you can take if you notice it. If you don't notice it, that's fine. Is the mass the same? Nope. So the mass does not appear in every term. You know what does appear in every term? 10 to the minus 27. You see that? Do you notice that? So we could actually cancel the 10 to the minus 27. As long as we're consistent in that, we can do that, right? Does that make sense? So we can go for M1, 1.67 V1I equals 1.67 times V1F uh, 6.65 times 2.25 instead of the 6. Do you know what else you could cancel out as well? You could cancel out the 10 to the 6 as well, right? But I probably wouldn't do that. I probably wouldn't cancel out the 10 to the 6 because when I do this math, I end up getting 5.61 times 10 to the 6. If I cancel out the 10 to the 6, I'm going to get 5.61, right? Now, if I remember to add the 10 to the 6 on it when I record my answer, that's great, but pretty good chance I'm going to forget that, right? If I cancel it to the 10 to the 6. So I'm going to leave that in there. We got 1.67 times V1I equals, now let's do that right-hand side. We're going to say 1.67 times 10 to the minus Nope, just 1.67 times negative 3.35 times 10 to the 6. And I'm going to add that to bracket 6.65. If you ever any trouble with the calculator entry, the keystroke entry, then like let me know. Or how to rearrange it or whatever. Times 2.25 times 10 to the 6. I'm going to divide that by 1.67. Gives me 5.61 times 10 to the 6. Which we're going to record. It says A, B, C, D, A, B, C, and D. Okay, how many people got that? Yeah. Oh, good point. Yeah, good point. That should definitely not say 10 to the negative D. Yeah, I didn't even notice that. That should definitely say 10 to the positive D. That would not happen on a unit test, and it wouldn't happen on a diploma exam. The more meaningful the test is, the more time has been spent, like catching things like that, right, Haley? Like on a diploma exam, like every question's been field tested and reread and proofread and whatever by so many different people that just isn't going to happen. Okay, on something like this, sometimes we can make a little error like that, but it should definitely be 10 to the positive. Thank you. Thank you for noticing that. All right, how many people got that again? Okay. Does the canceling out there make sense to you guys? 10 to the minus 27? Did anybody do that? No? Which is perfectly fine, right? Just means a little bit of extra keystrokes in your calculator, but it's not a big deal. If I spot a shortcut, I take it, but I'm not gonna spend 10 minutes looking for a shortcut. Okay, multiple choice number 1 now. It says a clerk working at a local food store is asked to retrieve the empty shopping carts left outside by shoppers. Each cart has a mass of 20 kilograms. The clerk places 8 carts which are locked together close to the entrance on a slight incline. The clerk gathers another 12 carts, pushes them toward the store entrance. The question hasn't really started yet. Now the question starts. The clerk gathers 12 carts, right here. Meanwhile, the first 8 carts roll toward the 12 carts with a speed of 2.3. They collide, they come to a stop. At what speed were the 12 carts moving just before impact? Here's what I want to do. There's 2 masses here, right? There's the 8 cart group of shopping carts, and then there's the 12 cart one. So I'm going to make it M1, and I'm going to make it M2. We don't really know what that mass is, do we? We don't know what the value of the shopping cart mass is. That's okay. We're going to say V1I is 2.3 meters per second. The 8 carts, before the collision takes place, are moving at 2.3, whatever their mass is. We're going to say that VF, everything afterwards is 0. So we're going to say VF is 0. Comes to a complete stop. And I'm looking for V2I, the 12 carts before the collision. So we say PI is equal to PF, M1 V1I plus M2 V2I equals, what do we want to make the final momentum? It all kind of comes together and stops, right? One object, it's 20 carts times the velocity of 0. Why don't we just make the momentum 0 then, right? Make sense? We're not memorizing that equation, right? Like we're figuring it out every time because it's always a little bit different. Or not always a little bit different, but often a little bit different. M1, oh man, what is M1? 8? Why don't I call it 8M? Times V1I is 2.3 plus 12M times V2I. I don't know what M is. Oh, does it? Oh, it does. Look at that. Okay. Yeah, never mind, I do that. So I could have said 160 there, right? And I could have said 240 there. Or 8M is okay. I just didn't need to do that because the M's have that cancel in there, right? So honestly, had I noticed the 20 kilograms there, I probably wouldn't have done it the way that I did it. I probably would have made it 160 and 240. But you can see that it doesn't really matter as long as you know the ratio there. It doesn't really matter what the mass of the cart is. 8 times 2.3, take it over by subtracting, divided by 12, gives me 1.53 meters per second. How would you, like, we could have almost guessed the answer was 1.53. Which one do we know 100% for sure would not have been correct? Yep. D. Yeah. If you had 12 carts going at 3.45 and 8 carts going at 2.3, they're not going to come to a stop, right? Okay, the 12 carts are definitely going to win. They have way more momentum. Probably not going to be A or B either because those are so small, right? Possible to be A or B, but such small numbers that it's not likely going to be that. C seems like by far the most reasonable answer, and it is the right answer. Okay, finally, number 2. A 2,100 kilogram van collides with a 1,200 kilogram cart rest. They lock together, move the speed 4.5. What's the initial speed of the van? Here's number 1. Here's number 2. M1 is 2,100. We're going to say M2 is 1,200. We're going to say something is 0, right, at rest? What's that, V1 or V2? 2? V2, yeah. V2I or V2F? V2I, yeah. They move off with the speed of 4.5. What's that going to be? Is it 4.5, Kira? Together, they lock together, they move off at a speed of 4.5. Yeah, it's going to be VF. So let's say PI is equal to PF, M1 V1I, plus 0, because the second car is at rest, equals M total times VF. And we're looking for V1I. Total mass is 3,300. All right, 3,300 times 4.5 divided by 2,100 gives us a value of 7.07 meters per second. We'd express that just like this in our numeric response answer sheet. Good? Is that it? Oh, there's more. Kidding me? There's a flip side of this page? Thought I was done. Bumper cars collide with each other. We want to know after the collision how fast X is moving. Let's make X number 1 and Y number 2. So let's say, do we know the masses here? Yeah, we do. M1 is going to be 1.25 times 10 to the 2. Well, let's just make it 125. Let's make M2, the second car, 161 kilograms. Let's make V1I. Car X is moving at 2.25. And let's make V2I negative 1.3 meters per second. Probably should have circled that, right? East and west. I remembered to do it, but I was also looking at my answer key. If I was doing this on a quiz, it might really be helpful to have east and west circled to avoid forgetting to make something negative. Car Y is moving at 0.526 afterwards. V2F is 0.526. We're looking for V1F. PI equals PF. Don't really have enough space for this one. Pretend you can make out what that says. M2 V2F, right? So what do we got here? M1, 125 times 2.25 plus 161 times negative 1.3 equals 125V. (161) times 0.526. So get this, get this, get this, take this over by subtracting, and divide by 125, and we end up getting A, 0.102. I didn't go through the keystrokes there. Make sure that you can get that. Okay, if you set it up like that and got the wrong answer, then it means you rearranged the equation incorrectly. Don't get a question wrong on a test because you rearrange it wrong. Like, you're going to make mistakes. That's okay. It's perfectly fine to make a mistake on a test. But you don't want to make a mistake. You don't want to waste a mistake on rearranging an equation wrong. Like, save your mistakes for the hard questions that are legit mistakes, right? All right?